All right. So in the last couple videos, we started to put into play some relationships that are very important in developing some sort of solution for each of these problems. Again, review that video and pay attention to the ones we starred because those are really the ones that allow us to make connections between numbers and or angles, and then find solutions. So we're going to take that a step further and talk about some more types of angles and lines that again help us to make connections so that we can push for solutions. And this will be the last instructional video of this week. So very important that you go back and review those three before we start working through the practice and the quiz on Friday. Okay. So today's video, okay, we're going to be talking about parallel lines and transversals. Okay, so parallel lines and transversals. Now, most of us know what parallel lines are, but we'll just quickly define those, right? So, parallel lines, one, they never intersect. Okay, so parallel lines never intersect. They can be denoted a couple of different ways. Okay, um, either with the parallel line symbol or arrows on lines. Okay, so for them to say line, right? Line A is parallel to line B, right? That means A and B are parallel to each other. I'm gonna, right? So there is line A, which means line B, right, would have to run parallel to it, meaning it's never going to intersect. So we are being told they are parallel, but they could also indicate that by drawing little arrows on the lines. Okay, so if you see something like that, that is an indication that these two lines are parallel as well without being given that information, right? So if we see these two arrows, that's what's going to tell us they are parallel. So these two are parallel lines. Well, we should know that, and we should be able to identify parallel lines. And what that's going to give us is a setup for the next part, what is called a transversal, right? Um, and so a transversal uh, is a transversal, okay, is simply a line that intersects two or more parallel lines. Okay, so if we draw our two parallel lines again, okay, um, right, doesn't have to be perfect, just close, right? These two are parallel to each other. Got our little arrows indicating that. And we can then transverse that line as follows, right, with line C. So in this case, right, line C would be the transversal. Okay, I think it's important we add that, right? Just for, um, right? So C is the transversal. Okay, and what happens is, if you'll notice, right, we've got a lot of things that are formed, a lot of angles that are formed, okay, using that transversal and those two parallel lines. Uh, if we only concentrate on one of these sections, so in looking at this one, right, if you were to look at just this section here, we've got, these are just vertical angles, right? So we've got what we've already studied, okay, and two intersecting lines here. The problem then becomes, what if they ask you the question about something up here? Okay, so information given here, how do we get up here? And that's what we're going to be talking about today, is making the jump from one set, which all of these would be vertical and supplementary, right? These two angles here would be supplementary, right? And then we have the across or vertical angle relationship here. So that allows us to, given any information in here, find out these four angles, and that's great. Sometimes we're just asked about those four angles, and we can answer that. But what then if we're asked about angles up here? How do we do that? Um, well, we have to have some relationships, and that's we're gonna talk about today, is the relationships that allow us, okay, to make this jump from one set of vertical angles to another. Um, and they're very simple and very intuitive. Their naming conventions pretty much tell the story on where you would find all of these. What I'm going to do now that we've kind of defined parallel and transversal, I'm going to go ahead and switch over to another page, because we're going to have a lot of definitions coming. I know I still have about half a page here to go, but that's just not going to be enough um, room to define all of the relationships that we need to define. There's actually four that we'll want to talk about. Okay, so going over to the next page, and we'll start with a very simple drawing. Okay, so that we can have reference. All right, so our drawing will be just as it was before. So let's draw two parallel lines. Okay, and there we go, right? We'll indicate they're parallel by drawing some arrows. And now we know they're parallel. And we'll draw our transversal. Now that transversal can be any which way. Switch it up. Let's go this way. So there's our transversal. Okay, so what I want to do is, let's go ahead and number these. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we've got 8 different angles formed there. Now, again, we can easily say that 1 and 4 are vertical angles, and therefore they are congruent. 1 and 2 are supplementary angles, and therefore they add up to 180. And 2 and 3 are also vertical angles, and so they are congruent. 3 and 4 are also supplementary. 1 and 3 are supplementary. 2 and 4 are supplementary. Okay. All of these things, right, we can say based on what we already know. The problem is, if we were given information about angle 1, how do we then answer information about maybe angle 7? And so we have to be able to make the leap from, right, a vertical angle situation into another vertical angle situation across this transversal. We have to transverse, right, between parallel lines. And so that's where our special angle pairs come in. And these are like I said, intuitive, but they have specific names and we need to know them. Okay, so knowing those names are what's going to allow us to make jumps. Okay, so corresponding would be the first one. Okay, so all right, corresponding angles. They are the same position, same orientation. All right. So what does that mean? Well, if you'll notice, right, uh, 1, 2, 3, and 4, and 5, 6, 7, and 8 are really just they are twins. Okay. So if I somehow could right cut this right in here, and I could slide 1, 2, 3, and 4 down into 5, 6, 7, 8 position, right? I could match these up. And so corresponding angles would be in the same place, right? So if I was to slide 1, 2, 3, and 4 down onto 5, 6, 7, and 8, if I was to, cut that there and move this top section down, I would see that 1 and 5, 2 and 6, 3 and 7, and 4 and 8 are all in the same positions, right? So that is what corresponding means, right? So how does that make us help us? Well, then that allows me to say angle 1 is equal to or congruent to angle 5, right? And we can add the congruency mark there. Angle 1 is congruent to angle 5. Angle 2 congruent to angle 6. Angle 3 congruent to angle 7. And angle 4 is congruent to angle 8, right? That's corresponding. These are all corresponding. 1 corresponds to 5 in position and orientation, okay? That means, right, they're corresponding. So if you're ever told that 2 angles are corresponding angles, well, then you know those 2 angles are equal to each other. Therefore, knowing the relationship helps, right? Okay, so our next relationship then is where we get a little fun, right? And with the naming at least, and that is alternate interior angles. All right. So just as the name implies, right? These are angles on the inside. Okay. So 3, 4, 5, and 6 are interior angles, right? So 3, 4, 5, and 6. They're interior. And alternate means they are on opposite sides. Okay. So opposite sides. Okay. So alternate interior angles are congruent as well. Okay. So we have, right, angle 3 is congruent to angle 6. Right. So if you look at those 2 angles, they are both on the inside here. That's what the interior means, inside. And we've got 3 and 6, right, are our alternating sides. So they're on opposite sides of the transversal. And by eye test, right, you can see those 2 do look similar. Okay. They're not in the same orientation, they're facing in different directions. But based on, right, alternate interior angles theorem, they would be congruent. So again, that's going to help me make the leap from 3, which is in this top set of vertical angles, down to 6, which is in this bottom set of vertical angles. Okay, so 3 to 6, I can get there. All I need to do is know, right, alternate interior angles are congruent. So I can jump from 3 to 6. The same can be said for 4 and 5, right? They're on the inside. They are alternate, right? So these two, they are congruent. So angle 4 is congruent to angle 5. Right? All right. So that's, two different relationships here, two of the four that allow me again to make the jump from the top to the bottom, or vice versa, right? Bottom to top. And that's all these relationships really help me do is make that jump. Okay. So next, we're going to go alternate exterior angles. Okay. So what does exterior mean? Exterior means outside. So these are the outside angles in our picture. So we're talking about 1, 2, 7, and 8. Those are all the angles on the outside um, of our alternate or our parallel line transversal. And alternate, again, simply meaning opposite. Opposite outside angles. Okay, so again, opposite outside angles. Put that again. That means angle 1 and opposite outside angles is congruent to angle 8, as well as 2 is congruent to angle 7. Okay, and if you reference back, you can kind of see by an eye test, if you drew it somewhat correct, right? Those two 2 and 7 again outside, so we're looking above and below the parallel lines. These are interior, these are exterior, and we're talking alternate, so they are on opposite sides of that transversal. So we've got 2 and 7, and again by eye test you would say, oh, they do look pretty similar, right? I probably could say they were equal. Well, we have this theorem which is proven through many measurements and trials and errors to be true. So 2 and 7 are in fact congruent, which allows me again to make the leap from the top to the bottom, getting across, right, this gap. So 2 to 7 and 1 to 8. Whichever one I know the other. Okay. So there's one more. Okay. And that is consecutive interior angles. All right, so consecutive, meaning one after the other, again, inside. Um, so in a row, right? That's what we're going to call consecutive, is in a row. Consecutive interior angles are inside, right? So we're talking about, again, 3, 4. So inside. So that is 3, 4, 5, and 6. Those are our inside angles in our example. Okay. Consecutive interior angles are supplementary. Right, which that word needs to spark an idea of 180 degrees. Okay. Consecutive interior angles are supplementary. And so what do I know? Well, I know angle 3 plus angle 5 equals 180, and angle 4 and plus angle 6 equals 180. Okay, and again, that's helping me make the leap, or even to if I know 5, then I know 5 and 3 together, right? These two together are going to form a supplementary pair. Okay. Um, and you might ask, well, how is that proven? Well, 5 and 7 are definitely a supplementary pair, right? They're right here. They are adjacent angles that form that straight line right here. So 5 and 7 are definitely supplementary. Well, 7 and 3, right, are congruent as well. So ideally, right, if 5 and 7 make 180, then 5 and 3 also have to make 180. Because again, the same is true, right? The same is true for alternate or consecutive exterior, meaning we've got 1 and 7 also being 180. So all of those things, again, help me make that leap across so that I can find solution. So let's pick up a problem here that we can look at and see if we can start to um, make some connections. All right, so uh, let's see. All right, let's start relatively small. Okay, so another. Right, so example 1. Okay, and we'll take this slow, but here we've got our parallel lines. Okay, and we'll draw our transversal here. And so there's our transversal, parallel lines, and we can say, let's just go same numbering convention, 3, 4, 5, 6, 7, 8. So given, and we'll just call this A, B, and C. A is parallel to B, and the measure of angle 4 equals 68. Find, right, the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle 4, the measure of angle 5, the measure of angle 6, and the measure of angle 7, and 8. Okay, so find all 8 angles, given that only the one you know is 68. Okay, so there you go. That one is 68 without a doubt. Okay, so 68 here, right? I know that. I was given that. So what can I say about all the rest? Well, very easily, right? Since I know my vertical angles are congruent, I know 1 is also 68. Well, that was easy. I've gotten so far, right? One answer right off the board. And then from there, right, we just need to know some of the relationships to make our way rest of the way. So if 4 is 68, then 3 is its complement. Okay. So 3, right, and not drawn to scale, obviously. 3 would have to be the supplement to 68. So I know 68 plus something is going to give me 180. So 180 minus 68, it gives me that angle 3. Well, angle 3 would have to be 112. Okay. And if angle 3 is 112, then angle 2 is 112 because they are vertical, right? So I've already got half of my answers down just based on some pretty obvious relationships. But now I need to make the leap, right? I need to get down to this set, okay? And so what I need to know is, right, some of those relationships we just went over. Well, 4 and 8, right, are corresponding. if I was to, again, slide this section down onto this section, it's going to match up. 4 and 8 are the same in that picture. Okay, so if 4 is 68, that means 8 is 68. Okay, and then 7 is its supplement, so 112. And 6 is vertical to that, so 112, and 5 is vertical to 8, so 68. And there you have it, right? We've now defined all 8 of those based on simple relationships, and so we can use that to move forward. All right, so taking it a little further. Okay, so let's go example 2, and gonna say, again, same kind of setup. Let's go this way with it, just so that our picture's a little different each time. And it doesn't matter, right? We'll draw our little arrows this time. That indicates that they are parallel. And let's have a transversal coming in here. And let's go with this is 8x plus 19. And this is 139. Okay. So, right, solve for x. All right. So, just so that we can have some talking points, let's put some of these 4, 5, 6. All right. So, I've added those numbers in arbitrarily. You don't necessarily need them. But what I do need is I need to know, right, the relationship between these two things, 139 and 8x plus 19, and some things that I know. Well, I know that um, angle 5 is 139 because they're vertical. That's easy, right? It's right there. So 139. Well, the good thing is, right, what I know is alternate interior angles are also um, congruent. So I can make the leap, right, that way. These are alternate exterior, so they're on opposite sides. And I also know those are congruent. So this and 139, those two are the same, which means they're equal to each other, which allows me, through alternate exterior angles, to say 8x plus 19 equals 139. Okay, and you can kind of see how we're going to solve now because we've got it set up, right? Alternate exterior angles are equal to each other, and therefore those two things are equal to each other. And now I can make that connection by subtracting 19, right? Subtract 19, so I get 8x equals 120. I divide by 8, so what is that? 15. So x is 15. Okay. And it's very simple once you know the relationships to make those connections. Right. So let's see, maybe just one more for today. And like I said, then tomorrow you're going to have some practice, and then we'll go on from there. All right. So yeah, this one looks good. Example 3. Okay, so go back to our horizontal convention for lines. These two are parallel. Okay, and we have a transversal here. And based on that transversal, we can then define some relationships. So we have 9x plus 14, and we have 3x plus 10. Okay, so there's our two problems. And they want us, again, just solve. Well, let's call this M. Solve for M. All right, so what is the measure of M? What is M worth? Well, I know these two are equal to each other, but I mean, there's not enough to go off of. I know that there's some more relationships here that should help me. Well, okay, if you'll remember, right, these two are consecutive, right? There's that angle, and then very next angle is that angle. So they are consecutive interior angles. Well, consecutive interior angles, what is that relationship? Okay, and you'd have to go back and read that, but I'll tell you now, right? Consecutive interior angles are supplementary. Well, what is supplementary? Right? What does that mean? Very important that you know what supplementary means. What does supplementary mean to us? Well, it should mean every time we hear that word, we should think 180. Okay, so I know that consecutive interior angles are supplementary, meaning they add up to 180, meaning these two things need to add up to 180. So I could say 9x plus 14 plus 3x plus 10 equals 180. Okay, and so knowing that, right, combine like terms, I've got 12x plus 24 equals 180. I'm going to subtract the 24 from both sides. Okay, leaving me with 12x equals 180 minus 24 is 156. Dividing that, I get x is 13. But they didn't ask me to solve for x. They asked me to solve for m. M would be the angle measure value. So I know that m and this 9x plus 14 are equal to each other. So m would be simply substituting in 13. So 9 times 13 plus 14 is 90 plus 27. That's 117 plus 14 is 131. So M must be equal to 131. Okay. M must be equal to 131 degrees. I know this video is a little longer, but there's a lot to go over when you're talking about the angle relationships. Please review the videos as many times as you need to, or pause them so that you can catch up on the notes. You're going to get lots of practice with these, and again, be looking for some independent practice coming tomorrow. That's going to be your homework assignment for the week. And then on Friday, we're going to be taking a quiz. As always, if you have any questions or comments, just shoot me a message. If not, thanks for your time.